Ladies and gentlemen, welcome all these women scientists who have made Chandrayaan-3 possible. Miss Nandini Harinath, Scientist Engineer, G, ISTRAC. Dr. Kalpana Arvind, Outstanding Scientist and Associate Director, LEOS. Miss Gomati Saratha, Scientist Engineer, SG, URSC. Ms. Kalpana K, Scientist Engineer, SG, URSC. Ms. Rupa MV, Scientist Engineer, SG, ISTRAC. Ms. Seena Sunil, Scientist and Engineer, G, ISTRAC. Once again, can we have a resounding round of applause for these women achievers? Thank you so much. And this panel discussion will be moderated by Ms. Sakal Bhatt. Ms. Sakal Bhatt brings to the table 23 years of experience in broadcast journalism, currently associated with DD India, external arm of national news broadcaster with international footprints, as senior consulting editor. Once again, let us all welcome these women scientists who have joined us to tell us the success story of Chandrayaan-3. For a journalist like me, because we come from Doordarshan, so all their missions, we've always had those live studio. Ma'am, I must say that goosebump mode. Okay, so thank you very much, and we're going to have a nice, free-flowing, candid conversation with these top ISRO scientists here. Some of the top ISRO scientists here, the top line. And it's going to also are able to connect and understand, though I understand that you all are mostly comfortable in English, which is absolutely fine, not an issue at all. We will have a free-flowing conversation, but towards the end, maybe last 10 to 15 minutes, you can please raise your hands. Do we have a mic here? Do we have a rotating mic here for audience? We can just have, maybe we can just check. Alkaji, if we can have a rotating mic here. If at all audience want to ask questions. And that's it. So Chandrayaan-3 के पीछे की और आगे की कहानी और हम कितना जल्दी 9 ग्रह पूरे कवर करने वाले हैं, 9 planets, 3 तो हो ही गए. So are we good to go? We can start the show. All right? Team? DD team? Okay. And yes, I would request you all to please keep your phones on mute. If not, switch off. This is, the signals are poor here, but still, keep them on mute mode. Which is my camera? You're my camera? Okay. Rolling. Namaskar and welcome to this very special and exclusive interaction with top-line ISRO women scientists present here with me. Highly distinguished women scientists who played a stellar role in successful launch of mission Chandrayaan-3. Ladies and gentlemen, can we have a huge round of applause? You're watching this. Thank you. You're watching this special broadcast on DD National, DD News and DD India, national broadcasters, which we bring to you from the sidelines of the 5th edition of India STEM Summit and Awards 2023. And it is imperative to once again point out here that this year's theme is Empowering Women in STEM. And this is also India's largest STEM education conference. Thank you very much, audience, for being part of this. And I must begin by sharing my experience here because I feel absolutely inspired and humbled to share space with highly accomplished women scientists of ISRO who have played stellar role not only in the successful launch of Chandrayaan-3, but the entire journey of Chandrayaan and much beyond. We do know that there are other missions that are also underway. We've already almost covered 3 planets, and we will want to know are we going ahead with the rest of the 7 or not? This session is going to be celebrating Chandrayaan-3 success, and these ISRO women luminaries are going to share their experiences, their stories, challenges, and those moments where they must have thought, what if Chandrayaan-3, the whole plan doesn't fall in place, what happens next? But most importantly, their contribution in Chandrayaan-3 has been highly, highly indispensable. It's a pleasure and honor to once again introduce on this show with us. I'm going to start with the face who needs no introduction, sitting right on my right. Dr. NitinGadkariOfficial Srivastava, Scientist G, renowned as Rocket Women of India. She holds dual role as scientist and aerospace engineer with ISRO, Deputy Operations Director for India's iconic Mars Orbiter mission Mangalyaan as well. Yes, you can put your hands together once again. No matter how much we applause, वो भी कम पड़ेगा. हमारे साथ है नंदिनी हरिरथ, Scientist G. Nandini Harirath again. They're all actually very familiar faces by now. She has had 2 decades of body of work within ISRO with profound contributions, and as we count, there are 14 missions Nandini ma'am has manned and has also contributed. Please put your hands together for Nandini ma'am. Her role as a project manager and mission designer has also propelled Chandrayaan-3 success, and also she's associated with Mangalyaan project. Let's also put our hands together with Miss Kalpana K. Miss Kalpana K, can we have Miss Kalpana K and a huge round of applause. Kalpana K, she's led the team successfully in the soft landing on moon. You know that moment where we all went like heart skips the beat, but then oh, ho gaya. She is also the one who has been responsible for that moment. Thank you very much, Kalpana K, for being with us, Associate Director, Chandrayaan-3. Also welcoming Miss Seena Sunil, Scientist G. Seena Sunil, Scientist G. Let's have a for her also. She's associated with various missions, Chandrayaan 1, 2 and 3. There are lots of stories जो हम आपसे जानना चाहेंगे. And Mangalyaan, Mission Aditya, Mission Gaganyaan as well. Thank you so much. Put your hands together for Miss Gomati Saratha, Scientist G, involved in Chandrayaan mission. She has been involved in this mission right from its inception. Especially, she has also been playing a very important role as an operations director for Chandrayaan 1 and Chandrayaan 2 and Chandrayaan 3 as well. The main operations, the critical operations. Thank you very much, Gomati Saratha, for joining us. Gomati Saratha here right on my right. And let's also put our hands together for Miss Rupa MB. Miss Rupa MB, Scientist G, Deputy Project Director, Chandrayaan 3, responsible for controlling Chandrayaan 3 mission, commanding, tracking, health analysis, and the list is endless. My God. This is so much. This is really, really too much, ma'am. The body of work that you all share. Dr. Kalpana Arvind is with us. Dr. Kalpana Arvind. Dr. Kalpana Arvind, she is an outstanding scientist and also Associate Director, she's here on my left, Associate Director LEOS, which is also a unit of ISRO. Her responsibilities includes delivery of all types of sensors. Now sensors are very important, uske bina to kuch ho nahi sakta. Eyes of satellites, and they are the sensors which are flown in orbiter, Vikram rover, and much more. So I'm going to quickly start because मैंने बहुत बोला मैम अब आपसे सुनना है आप ही से शुरुआत करेंगे तो सबसे पहले तो रॉकेट वुमेन ऑफ इंडिया से हम जानना चाहेंगे वो जो कुछ सेकंड थे you know what I'm saying कुछ सेकंड थे and मैं हमेशा से ये सोचती थी कि मुझे मौका मिलेगा तो मैं ये पूछूंगी thanks for the ride mate ये कैसे आया
देखिए जैसे आपने बताया वो जो कुछ क्षण थे लास्ट के वो इसलिए बहुत ज़्यादा महत्वपूर्ण थे या बहुत ज़्यादा मतलब टेंशन वाले भी थे क्योंकि उसके पहले हमने चंद्रयान 2 अटेम्प्ट किया था और चंद्रयान 2 वाज आई कैन से इट वाज अ सक्सेसफुल मिशन एंड इट्स ऑर्बिटर स्टिल इट इज़ रिवॉल्विंग अराउंड द मून अभी भी बहुत सारे डेटास भेज रहा है लेकिन जो उसका लैंडर था और हम सब ने बहुत मेहनत से वो काम किया था विक्रम और प्रज्ञान और सतह के बहुत पास आकर few meters away we lost the communication. तो वो जो क्षण थे, उस समय वो क्षण जब चंद्रयान 3 लैंड हो रहा था, तो वो क्षण ज़्यादा दिमाग पे चल रहे थे। क्योंकि इतना चैलेंज और उतना है, तो जो हमने उसमें इम्प्रूवमेंट्स किए हैं चंद्रयान 3 में, क्योंकि उससे जो हमने लेसन्स लर्न किए, तो जैसे आपने बोला राइट थिंग ढूंढना, तो वो जो लेसन्स लर्न थे, बिकॉज इन चैलेंजिंग मिशंस में जो चुनौतियाँ होती हैं, वो हमारे पास बहुत सी ऐसी चीज़ें होती हैं जो हमें पता ही नहीं होती कि हो सकता है कि वो कुछ गड़बड़ हो जाए. दैट इज़ कॉल्ड अननोन अननोन्स. So that is
So
not
there are known unknowns and unknown unknowns.
unknowns. So we were not knowing कि हो सकता है, मतलब ये आइडिया भी नहीं है, थोड़ा सा भी नहीं होता है कि ये गलत हो सकता है. लेकिन उस फेलियर ने जो हमें डेटा दिया, उससे जो हमें लर्निंग्स मिली, we got wealth of data. So it was, I can say that Chandrayaan 2 itself was a successful mission which laid the path for this successful Chandrayaan 3, because it gave us so much of learning, so much of improvement we could adapt in Chandrayaan 3 Vikram. And that is how that last moments I was really, I can remember, and I was only remembering those Chandrayaan 2 moments. And then when Chandrayaan 3 landed, it was like,
Finally Chandrayaan 3.
It was unexplainable moments. I think Kalpana will share with
Kalpana,
me. It was unexplainable.
We saw you on TV on the live broadcast that day.
Thank you. Yes, as Ritu has rightly started, Chandrayaan 2 was a very challenging mission, as you know, because it is quite different from the routine communication satellites or the remote sensing satellites which we used to do. We did have a Chandrayaan 1 orbiting mission, but next Chandrayaan 2 was a total different ball game because it was a landing mission. It's a mix of satellite and rocket technologies. We as a team did our best. We learned many new things, new advanced technologies, and we did our best and did go ahead with Chandrayaan 2. But we did not reach the final goal of soft landing. But we had learned a lot of new things from that mission, because almost all the advanced technologies what we had built, we had proven it actually. So that was the beginning. But we had to succeed and show what we really planned for. That's how Chandrayaan 3 was built. But when we started off for Chandrayaan 3, we did it in a very systematic way. Yes, we had the pressure that we are going for the second time. It's a big responsibility on our team, on our shoulders. But we did it in a very systematic way.
What was the kind of success rate that, were there moments when the team thought that, what if?
Moments will be there, but without that 200% success, we wouldn't have rolled out the satellite from our URO satellite center. When we rolled out, it was with utmost confidence that we went ahead, because we know the responsibility on our shoulders. So whatever required, be it the reconfiguration of the satellite, that is the lander, or the robustness what we built in the lander, because this time what we did was all the intelligence which is required on the lander, that we had built it. Because you all know that complete 20 minutes what happened is a complete autonomous landing sequencer. Like we also don't have an option but to only sit and watch. All the challenge what we had was build the intelligence in the lander, that the lander can handle a big amount of dispersion. That is what we call more efficiently the lander can handle the dispersion cases. That's what we built in. And apart from that, building it or reconfiguring alone is not sufficient, but we have to do enormous testing on ground before we send it, because you all know the moon environment is different, the earth environment is different. But we have to bring the confidence of ensuring that the lander is going to work very well on the moon. So the enormous amount of testing and also the simulations what we did. All this put together, I would say, the culmination of all these 4 aspects, I would say, is the confidence what we built, and we rolled out the satellite from URO Satellite Center to our launch base, Sriharikota.
And what a moment it was. What a moment it was.
Yes. And further what happened, all of you would have seen it live,
Yes.
be it
Yes,
the launch or the landing. That was the ultimate moment. And what we all cherished, I would say, is it was not just a success of our scientific community or engineering community. It was a success which a whole nation celebrated. It had become every household name. I think this was the ultimate satisfaction which our team had obtained from this mission. It has reached irrespective of age, from
Absolutely.
children
It brought
to
the whole
senior
nation
most.
together. There is
That was the
absolutely
next.
no doubt about it. And I think you would agree that apart from cricket, this was one of those, TV moments. Everyone was, okay, thank you. Everyone in the household was glued to TV sets. glued to Doordarshan, our Doordarshan, irrespective of whether we understand the nitty-gritties of science or not. I think this was something which scripted history for the nation, and I think आगे चल के हमें काफ़ी कुछ और भी स्क्रिप्ट करना है. हम मंगलयान पे काम कर ही रहे हैं, हम सूरज के पास भी जाने की कोशिश कर रहे हैं, उसके अलावा हमारे पास 7 और ग्रह हैं. हम आगे क्या क्या कुछ करने वाले हैं. मैम, नंदिनी मैम.
Thank you. So yeah, while we worked for Mangalyaan 1, and I was like involved from the scratch when the project came in, and at that point of time, none of us had any experience in working for an interplanetary mission. It was the first time we had all started reading about how to start and how to design and develop an interplanetary mission. So we've all been groomed from there, and it was like hours and hours of work. After Mangalyaan, of course, the Chandrayaan series, and then now the satellite is going towards the Lagrange point. It's not going close to sun, but it's just going at 1% distance to the sun.
Can you explain?
Yeah. So Aditya L1, the sun is 150 million kilometers away, and the satellite will be going to a point 1.5 million kilometers away. The speciality of this point is that at that point, the gravitational forces of the sun and the earth nullify. So it's called a stable point. And the advantage the point gives us is that you have an observation to the sun.
We'll be the first nation to be as close to the sun?
There are missions earlier who've gone, but the speciality about this mission is that it carries various amount of instruments which will study the entire aspect of the sun, whether it's the coronal mass ejections or the solar flares. So, in fact, it has instruments which have wavelengths right from the ultraviolet to the infrared. So we'll be.
This is so exciting.
Yeah. So, and like these are. Interplanetary missions are always challenging, and they bring about so many surprises and so many new elements. And there are study groups working towards missions to other planets. We don't have the projects approved as yet, but as study teams, a lot of work is going on, a lot of research is going on on how to reach other planets. And in fact, asteroids are also interesting bodies to study. So there's a big asteroid belt. And there are studies for that too.
So India is, ma'am, I would like to ask this, Kalpana. Yeah, Kalpana ji, just to add further to it, we would also like to know, besides the whole mission aspect, whatever you can share with us, uske alawa, the whole journey for a woman scientist, balancing home, and I can see all of you nodding, balancing home responsibilities, and I think this kind of work where you have humongous national responsibilities on your shoulders and they are non-negotiable, whether it is Chandrayaan 1 or 2, and then back home you're a wife, you're a homemaker, you're a mother also. I would want to understand from you, especially after Chandrayaan 2, the kind of sacrifices each one of you made, and what has been your biggest support system on the family front?
Thank you for that question, because this question applies to all the women who are very well aspiring to become a scientist or a doctor or in any profession. Women are, earlier it was considered like they are only closed door inside the house and only to cook. Now the technology when we started engineering in the years 1980s, people used to ask why women has to study engineering. Now the thing has fully reversed. For the past 3 decades I am seeing there are women scientists, and even in ISRO itself we are almost nearing 33% in most of the centers, and in my own unit I can tell we are almost 40% women are there. So that is ISRO is going forward, and I can say there is no gender bias in ISRO. And how we manage, because not everybody can come to the top, because we have to balance between the house and the office. If we see in any organization or even at MNCs, the number of employees or the women who are in the top post is very few. We can count it. It's because we are still lying between the thin line between the family and the office. So to manage these two, our family support should be there. If that is not there, it is really very difficult for a woman to lead. So earlier there was a quote like, for every successful man there is a woman behind it. But now I'll say, for every successful woman there is a family support behind it. And when Madam told, Chandrayaan 2 itself was a big work for us, being coming from a sensors division where we normally make sensors for all the low Earth orbit and geosynchronous orbits. And though we have made sensors for Chandrayaan 1, it was going around the orbit only. It is similar like sensors which just it has to tell the rotation and what rate it is moving, the spacecraft. But when you are learning on a surface, it is an entirely different reason. So we need to make navigation sensors. What we make rotation sensors, compared to that, we need to make a velocity measurement plus position of the landing with respect to the moon surface. So these two things we need are different technologies, and in ISRO we always work with redundant systems because we won't take any risk involvement. So we from LEOS we have made laser based altimeters, and our SAC Ahmedabad team has made a carband altimeter which is an RF based. So in the system wise also we ensure that the technologies are different. So that is the first thing we do. And the second one, for the velocity measurement also, what is the way, though accelerometers are there and gyros are there in all the systems, but they are all not an absolute sensor. They need some update because they drift with time. Unless we correct the proper update at the proper time, we cannot land correctly at the place where we wanted to land. Because it was a difficult task from the beginning, Chandrayaan 2, we wanted to land in southern pole, where lot of craters were there, the surface uniformity, things measuring, and what is the intensity, what is going to come back, because if we use a camera, what should be the integration time, because the picture is very important.
So if I have to break it and simplify it for the non-scientific community, because everybody would not be able to understand the nitty-gritties of science, including me. You must have worked on, and ma'am can take this one.
Just I wanted to tell, women has to be supported by the family. Then only it is possible for us to work together. Thank you.
So there must have been thousands, or rather lakhs, of known and unknown scenarios that you and your team, hypothetical scenarios that the entire team would have worked on, and thousands hours of research as run up to Chandrayaan 3. I mean, when you think of it, it is like, kya ye ho bhi sakta hai?
Yes, definitely. Chandrayaan, our team responsibility was each and every command, whatever the command goes to satellite, it is our responsibility. And the telemetry, whatever from the Chandrayaan 3 we are receiving, the telemetry we have to analyze, health analysis, and if any correction measures that we have to do. For that, so much ground system also we have to make it ready. For Chandrayaan 3, it is not one ground antenna, two ground antenna. We made ready for 25 antennas around the globe, made ready, and out of 25, almost 18 antenna we used it for Chandrayaan 3 operations. And the communication established from all antennas to our center. For everything, we see that the perfection, and do a lot of simulations, because we don't know the unknown roles in that, because each and every format of Chandrayaan 3 should support by each and every antenna or each and every system in that. So complete ground system readiness for this is also one challenging
But at the end, all fell in place, ma'am. Can you take us through the experience?
I just want to tell, see, I joined with Kalpana madam that this time in Chandrayaan 3, the country was with us, even every moment, you know. So normally any success in ISRO, we celebrate as the team ISRO success. So this time it was the nation's success.
Absolutely.
So that we have to tell. Then about my experience, basically I'm a mechanical engineer. So when I took my mechanical engineer, there were a lot of issues because very few girls will be coming forward for mechanical engineering, and I was also worried it will be more of automobile and the boys domain. So when just joined ISRO, just felt that it is totally different this one. As a morning session, Dr. Sitaram was telling, it was basically a multidisciplinary topic. Where I work in the ground station antennas. It consists of mechanical engineering, it consists of electrical engineering, and it is more of radio frequency, RF engineering and electronics and different materials. So what I feel, there are a lot of opportunities for the young girls and also for the boys. Once you are coming to ISRO, you have to be a multidisciplinary person. You should not restrict yourself to the domain. So that approach anyway, as they told in the morning session, STEM is encouraging. So if you are having that exposure to the different technologies, you can be definitely successful in ISRO. And in ISRO, I just want to tell, as Madam told, in our center also, we are having almost 27 to 30% women scientists and engineers. And it gives a lot of satisfaction. I was just telling the other lady that day, every day when we are coming, we are getting new challenges, which drives us. See, if the job is routine and it's becoming monotonous. But in ISRO, I feel everybody, all of us will agree, every day.
So ISRO's crack team includes more women, if I can safely answer this question.
Yes, looks like.
Ma'am?
It is like a mix-up.
Thank you for first the organizers. I will thank them a lot choosing like women scientists to founder on the Navaratri day, basically. The word Chandrayaan, it's the word started in 2001 onwards, which like first the name coined with Somayana, and the name is Chandrayaan. The word itself is a very interesting word for us. And from the journey behind for this Chandrayaan is 20 years back, where the 2 decades back our seniors, many things they have done and they left us for the things to move forward. When we started Chandrayaan 1, there was no Google that time, there was no internet that time. So we were searching for each and everything, how to capture the moon, how to go out of Earth. That was the first experience which we had. How to go out of Earth, we are always bound with Earth. So that was the first time which we went for the Chandrayaan 1, and when we captured, that was a very interesting experience which we had in 2008. And the impact probe when we had and when it went to Jawaharlal. So that was an impact when the first Indian flag which came to the moon. So that was an interesting experience for us, and the Chandrayaan name itself came into a coin and it landed there. The successor of this Chandrayaan 2. When Chandrayaan 2 was launched and when we got into a moment when we couldn't land, and we are continuously taking images for the next 4 or 5 days where to search the lander. Because it is not where here we can go and take with the police and this thing.
I'll just interrupt you here. Since you are now, ma'am is so beautifully telling us, am I audible? I think. Okay. Ma'am is so beautifully telling us about the entire journey 1, 2 and 3. Now, a brief pause at 2. Chandrayaan 2. First of all, obviously when you're working for a mission, you're working on the unknown knowns and known unknowns, but you're not prepared for that mission to fail, God forbid. But anything can happen. But whatever happened at the end of Chandrayaan 2, was this ever imagined that it may not happen? I mean, that disappointment, whatever happened. We did not even understand. I mean, it took a lot of time for us also to understand that the mission has not been successful. Would you like to speak about that?
Yeah, slightly I will modify your sentence. Whenever we plan anything, we plan the success part, and if not, what to do then next.
Yes.
So that planning is also always goes in ISRO for the every aspect of ISRO. Today when we are coming here, if you are not able to reach in time, what is the next plan?
Plan B.
The plan B is always
The plan C will be there.
Yeah. So that is the plan which always ISRO is driving for each and everything. So when we couldn't land and when we were not able to do it, the next consecutive 3 days where each and everybody we struggled to find the lander and with the Chandrayaan 2 orbiter images where exactly where it has gone. So that was a really challenge for us to search the lander basically. So that we hope we could find within some 2-3 orbits itself.
How did you all actually overcome that challenge of coming out of that failure, if ma'am can take that one, and move on? It is not easy, ma'am.
Yes, because I would say Chandrayaan 3 itself is the best example for everyone, particularly for the students and every other person.